So now let's talk about cones. Just like prisms and cylinders are very much alike because they have two bases, it's just that the basis of a cylinder is a circle. Cones and pyramids are very much alike because they have just a single base and they come to a point or a vertex. So a lot of what we already know about pyramids we're going to apply to cones. It's just that the shape of the base of a cone is a circle. And we can have an oblique cone or we can have a right cone. And a right cone would look like this. All right, so this top point is still called the vertex or the apex. And the altitude is still the segment going from the vertex to the center of the circle. We know that we have a radius of a circle, and just like with the pyramid, we have a slant height. The slant height is the segment from the vertex to the edge. And this does make a triangle. So let's remember in a pyramid we had a right triangle, slant height, apothem plus the altitude squared. So in a pyramid we had the height, we had the apothem, and we had the slant height that created a right triangle. We have the same type of triangle in a cone. It's just this is not called an apothem. This is called a radius in a circle. But it's really the same thing. It's the distance from the center to the edge. So we'll still need potentially the slant height. We'll need the slant height for a cone, or that's a measurement that we might have. So the base is a circle, the vertex is a point, there's a height or an altitude, there's a radius, and then there's also a slant height. So as a reminder, the distance from the vertex to the base is the altitude or the height. That goes straight down from the vertex to the center of the circle. The distance from the vertex to the edge, to any point on the circle, that's called the slant height. So that would be the height, and that would be called the slant height. All right, so let's remember for a pyramid, the lateral surface area is equal to 1/2 the slant height times the perimeter. Well, we don't really call the distance around the outside of a circle a perimeter, so for a cone, the lateral area is going to equal 1/2 the slant height times the circumference. That is what we call the distance around a circle. But it's basically the same application as a pyramid. So we're not going to worry about inscribing and that getting bigger and bigger and bigger. We're going to go right here. We have the lateral surface area is 1/2 the slant height times the circumference. But if the circumference is pi times pi times 2r, the 2's are going to cancel, so the lateral surface area is the slant height times the radius times pi. If you wanted a simplified formula for lateral surface area of a cone. So the lateral surface area of a cone is 1/2 the slant height times the circumference, if you're given circumference, or you can simplify it to the lateral surface area is pi times the radius times the slant height. Basically, the 1/2 and the 2 cancel. That's the only difference between the two equations. Now, once again, what about total surface area? For total surface area, we'll need the lateral surface area plus the area of just one base. A cone has just one base, whereas a cylinder had two. So the total surface area is the lateral surface area plus the area of the base. What did we say the lateral surface area is equal to? Pi times the slant height times r. And what's the area of a circle? Pi times the radius squared. That's what you would use to find total surface area of a cone. So we're going to do a practice here. For this right circular cone, here we have a radius of 3 and a height of 6. They want us to find the exact and approximate lateral surface area. Okay, so we have a height of 6 and we have a radius of 3. We're going to use that to find slant height. Slant height squared is 6 squared plus 3 squared. Slant height squared is going to be 36 plus 9. Slant height squared is going to be 45. So what is my slant height? It's the square root of 45. So what is my lateral surface area? Lateral surface area is 1/2 slant height times circumference, or 1/2 square root of 45. And what's the circumference of a circle? 2 pi times the radius. Okay, so let's cancel the 2 in the denominator and 2 in the numerator. Our lateral surface area is going to be 3 pi times the square root of 45. And square root of 45 is the square root of 9 times the square root of 5. That's 3 pi times 3 square root of 5. I'm going to multiply the two 3's. That's going to be 9 pi square root of 5 in centimeters squared. That is the exact. That is the exact lateral surface area. And if you want the estimate, just put this in your calculator and we'll use the calculator value for pi and we'll use the calculator value for the square root of 5, and you'll get that it's about 63.22 centimeters squared. That's an approximation. So we have our exact value and our approximate value. Now how about we want the exact total surface area and an approximation of the total surface area. So the total surface area is the lateral plus the area of the base. So let's do exact first. Our lateral surface area in exact numbers was 9 pi square root of 5. And what's the area of a circle? Pi times the radius squared. So the exact value is 9 pi square root of 5 plus 9 pi centimeters squared. And if we want an estimate just put it in your calculator. We'll use the calculator estimate for pi and the calculator estimate for the square root of 5, and you'd get it's about 91.50 centimeters squared. And remember, area are square units. So that's my exact value and my estimated value.